Okay, before you have to look at the next few videos that are like 30 and 20 minutes long and decide if this is actually something you need to use, I just wanted to give you background about what this playlist is really about. So I've been involved recently during my postdoc at my university with historic seismic data, and we've just realized that problems with the coordinates in the header files and the headers of the SegWire files can actually create problems when viewing your data in 3D. So let me just show you an example. So all of this is part of an abstract I did for the EAGE conference this year. And just scrolling down, so this is the seismic line I was looking at. And you can see here, these are the CDP values, I think. And instead of, you would expect one being at one side of the line and the numbers increasing to the other, actually the value, the first CDP is in the center of the line. It increases to 565 here. There's a whole bunch of other shot points, these dots that are spread out in between, getting you back to 577 in the middle, and then it increases to 1000 in this direction. And you can see here, these sparse dots in the middle are numbers, are CDPs 566 to 576. So the CDPs are just all over the place, and therefore so are the coordinates. So it's not increasing in one direction. And so the big thing was to get this data, these coordinates, into GeoSoft and literally just sort it increasing from bottom left hand side to top right hand side, so southwest to northeast, and then take the data, put it back into SegWire files, and then plot the SegWire files in Kingdom and see what they look like. So I mean, these tutorials are just about how do you get XY data out of a SegWire header, and how do you put it back once you've fixed it. And so you can see here, ignore that up there, but this is what the line looked like in 3D in ViewPack before we fixed it. So you can see here's the strong reflector at the basement, there's something going in the middle here, strong reflector seems to go down again instead of you'd expect it to go up, and then you've got the stretched out region. And this is actually because of this weird directions of the CDPs. So instead of this basement going from deeper to shallower, because the numbers were flipped around, it's actually going deeper, shallower, and deeper again. And then because of those spread out points, you've got the stretching. And then actually in the middle here, you can see the line, there's a split in the line, even though, so it should have been two lines, but it was actually merged together as one. And so that's what causes the stretching in the middle. That we can't actually fix, but this bottom bit we can fix. And so just importing the coordinates into GeoSoft, sorting them, and then putting them back, that's what the line looks like afterwards. So I mean, a huge improvement. I need these on the same page, but I mean, you can't even interpret this side of it. And so that's what led me to do these videos. The video that I've done is actually on different data that aren't as, there isn't as strong a change. So by the end of this, I'm like, well, was it actually worth it? But it always is worth improving your data. And so you're not adding or taking away anything with the data. Like it's already, this data was already processed. I'm not reprocessing the data. All I'm doing is changing how we view the data in 3D. And what might happen is you see this and you go, oh my word, this data is a disaster, we need to reprocess it. And reprocessing takes time and skills. So rather try this method first, see if it's your coordinates that are a problem, and you can get great data like this without having to reprocess it. It took me, once I knew this process, this probably would have taken me an hour or two to do. So that's why you should watch this video. If you're someone who's into seismics, if you've got historic seismic data, and you've got some data that looks a bit weird. It's mainly the stretching that you can see. It's not always a big zone, it's often just the small zone over here. I can quickly just show you on the current data that I'll use for this tutorial. You can see this is the stretching over here, and it was a result of the fact, let me quickly jump back here, this is my location data. It was a result of the fact that in the middle of the line, over here, the red, the red is the fixed coordinates, the black is the original coordinates. So you can see the black coordinates were coming down here, there was a gap in the middle, it came down, and then this line was coming up here. It's because this line is made up of 5 segments and it wasn't merged together properly. And so because of these additional points here, that is what is causing the stretching. So how do you fix it? Something to just mention is that you might not find this that important if you're just viewing your data in 2D. So this is the unfixed data in 2D, and whereabouts is that section? I think it's about here. You'll actually see this T doesn't go away when you fix the data. That's, I think, something from the original processing and original data collection. So it's not as clear on when you're viewing it in 2D, but it's when you put it in 3D that you start seeing the stretching, because you're taking into account the coordinates of the line. So yeah, that's for an explanation of who should be viewing this video.